Welcome to classes on organic chemistry. Today I have taken a chapters on aldehyde and ketones. After completion of this chapter, I have started solution of the chapter, textual solution and in-text solution. And one of the suggestion for the dropout student, those who have already passed and they are trying for next attempt of neet or other exam, they should not skip the questions or the solution of the chapters, because a lot of questions are inside the solution which are very often asked in the competitive exam. In due degrees, I will solve one question which was asked in 2022 on cross aldol, which I have not discussed. I will discuss in detail in course of my solution. So first uh, one question from the text. Used reagent used for conversion. So reagent used for conversion, hexane 1-ol, hexane 1-ol to hexanal, that is OH has converted to CHO. What reagent? Reagent is PCC. Hexane 1-ol to hexanal, because alcohol is being converted to aldehyde, so we need a weak oxidizing agent. We should not use strong, because if you use strong oxidizing agent, OH will instantly convert into COOH. So we need PCC. The formula C5H5NH I have shown you earlier. PCC. Number 2, cyclohexanol to cyclohexanone means OH to own. Am I right? Nol, hexanol to hexanone, OH to this. We need anhydride CrO3. Number 3, parafluorotoluene to parafluorobenzaldehyde means this is very simple. Our target is just to convert toluene to CHO. Am I right? So one of the very important reaction in name reaction I told you, then CH3 in aromatic compound CH3 becomes CHO only in presence of chromal chloride. It is Itard reaction. Am I right? Very simple. CH3 becomes CHO in presence of chromal chloride, and the name reaction is called Itard reaction. The name reaction is being here used. Ethane nitrile to ethanol means nitrile means CN group is converting to CHO. Very famous reagent. I have talked a lot. Diabel. DIBALH. And allyl alcohol. Symbolically, let me write allyl alcohol to um, OH is becoming to CHO. What reagent? Again, reagent is PCC because here double bond is not touched. You can write it in this way: CH2 double bond CHOH to CH2 CHO. CH2 CH2OH. Am I right? Then CH2 CH, that CH2OH is becoming this. The reagent is PCC. Next one is but2-ene to ethanol. Here you have to think a lot, a bit, not a lot, because your compound is double bonded compound and you are asked to find out Al means CHO. Let us write from this you are getting ethanol. Am I right? So this is nothing but ozonolysis. When ozonolysis is done, you will get in this way ozonite, and on ozonite I have shown you earlier CH3CHO. So your reagent is used as ozone zinc acid hydrolysis. Am I right? So this is the first part of the question asked while the chapter is discussed. That is, these questions are inside the chapters, not textual. Next part is benzene. This is given in this way. And you are asked, what is the product? Answer is very simple. Aluminum chloride takes away this chlorine, that becomes AlCl4, and C6H5CO becomes electrophile, and that electrophile enters there. Very simple. This is the answer. Friedel cupped acylation. Very simple. I am showing you. This is C6H5CO positive. Am I right? that is C2H5CO positive, and that CO positive is an electrophile attached electrophilic substitution reaction in benzene. This is the answer. You need not show the mechanism, just I have shown you the process. Next one is given in the chapter, and it is very important. You have got in first year also. Means it is a very famous reaction, and sometimes H2 positive is given, HgSO4, and H positive is given, H2SO4, and it is dilute. When it is dilute, there is water. Am I right? So when is water, then water is breaks into this two part. So first of all, you do one thing. Markovnikov rule: negative part will get attached to that carbon along triple bond where hydrogen is less. So your answer is CH3 OH bond C double bond C, and that H is here. Am I right? But that is very unstable one. Tautomerization occurs. Tautomerization occurs. Very simple answer. This is acetone or propanone. Am I right? Next one is next question. 1, 2. Third one is again very simple. Paranitro, toluene, chromal chloride. Earlier at the very beginning I told you it is type of beta reaction where CH3 becomes CH2 in presence of chromal chloride. Very simple. So this is second part of the solution of your chapter. Next part is 12.14, page 386 of textbook. How will you the following from benzene? Number 1, benzene to you are asked to prepare this from benzene. So to think about the product, it is impossible to get. So let us start, and I will explain in course of time. Benzene, anhydride, aluminum chloride, CH Friedel-Crafts alkylation. CH3Cl, Cl will be get attached into AlCl3. This will be CH3 plus electrophile, and that electrophile will enter into this toluene. So when you get toluene, our main aim is to get C double O CH3. It is ester part. Am I right? To get ester, it is not possible to get directly ester. So we will oxidize it by KMnO4 in presence of base. We will get benzoic acid. So in carboxylic chapter, I have already shown that acid, when reacts with alcohol in presence of sulfuric acid, it gives ester. So let us take alcohol, ethanol, in presence of acid, just what will happen? Carboxylic acid and this alcohol, acid and carboxylic acid in presence of H positive, it gives ester, C double bond O, and that part will get attached. This is esterification. This is methyl benzoate. You are asked to prepare methyl benzoate from benzene. So we have got from benzene methyl benzoate. So second one is you are asked to prepare metanitro-benzoic acid from benzene. Metanitro-benzoic acid from benzene. Take benzene and you see gives anhydride aluminum chloride, Fadel alkylation. Once again you will get toluene. You make oxidation with this, CH3 group will become COOH, and this is metadirecting. COOH and CHO are metadirecting. That incoming electrophile will be dictated to enter into the meta position. So in meta position, what we need? We need nitro. What is nitrating mixture? It is concentrated HNO3 and H2SO4. Out of this we will get nitrating mixture, and this NO2 is an electrophile, will be directed to enter in the meta position since COOH is meta directing group. So this is the way how we get metanitro-benzoic acid from benzene. Next one from benzene you are asked to obtain paranitro. There is a bit complexity is there. I will explain in course of my explanation. So earlier you were asked to calculate, you were asked to prepare nitro in meta position, means metanitro carboxylic acid. Now you are asked paranitro, sorry, not carboxylic, benzoic acid. So what we do here is our starting material is benzene. Minutely follow. Again we are using the same reagent to get up to this much. Toluene is okay. Now after this position we directly make oxidation. We made oxidation to get carboxylic acid, because if you do not bring carboxylic fast, it is not possible for us to get nitrogen in meta position, because carboxylic is acid, COOH group is a meta directing one. That's why we directly converted CH3 into COOH by oxidation, so that incoming NO2 will be entered in the meta position. But here the matter is different. We need NO2 in the para position. So if we now oxidized like earlier, then COOH again direct the nitro group to enter in the meta position. So here before oxidation we will make nitration, sulfuric acid and this nitrating mixture. Here from this we will get what? Nitro, NO2 positive nitrating mixture. It is electrophile, and since it is a para-directing and ortho-directing group, it will direct the NO2 group electrophile enter either this position or that position. Since para position is maximum, we will get nitro group in para position. Mind that earlier we did COOH here, because we get COOH and that directed the nitro group to enter in meta. Now before oxidizing CH3 to COOH, we have done nitrating mixture first, Because CH3 will dictate NO2 group to enter in the para position. Now we will make oxidation with KMnO4 like this, so that that one will oxidize CH3. Alkyl part will oxidize in presence of strong oxidizing agent into COOH group. It is known to you all. If it is C2H5, it is whatever the thing. If it is 1 degree, 2 degree, not 3 degree, that whole group will become COOH. It is rule COOH NO2. So we have got this. Next one is benzene 2. You manually follow, you can understand. Benzene 2 is phenyl acetic acid, 1 phenyl acetic acid, CH3 COOH acetic acid. See, in one position, one hydrogen is removed and phenyl group is under 1 phenyl acetic acid, benzene 2 phenyl acetic acid. How will you get? Just you think, we need this to this. So what's happened? First of all, as earlier, we will do anhydride, aluminum chloride and CH3Cl will get toluene. Am I right? This part is simple, toluene. Now thinking is needed. What we required? We required the reaction on side chain. Am I right? So we'll do what? If it is, you forget about benzene, if it is methane, in earlier classes, 2 class earlier I told you, if it is methane, alkane, we need alkyl halide. Then alkyl halide is replaced by CN. Then CN is done. We do something along with CN. So we will do what? We will use bromine here. We want to make side chain reaction. So if we use bromine here and CH2 here, bromine will instantly enter in this position. Am I right? In carbon disulfide solution, once in ortho, other in para as electrophile. But where we will do to make the reaction side in CH3 group, we will boil it. Am I right? So what will happen? We will get CH2 Br. Now when alkyl halide part is there, we will just treat it with KCl, so that cyanide part. In very beginning of the alkyl aldehyde chapter, I told you, when CNO group is there and it is acid hydrolyzed, that group becomes COOH. That group becomes COOH. So this is the desired answer. Very simple. CN becomes COOH on acid hydrolysis. So 1 phenyl acetic. Next one is benzene 2 paranitrobenzaldehyde. Benzene 2 paranitrobenzaldehyde. So what we had do? Benzene, anhydride, aluminum chloride and CH3Cl. Again we will get toluene. Am I right? Again we will get toluene. Very simple. We want to introduce NO2 group. Am I right? So NO2 group will best be introduced in ortho and para position. Para position is maximum and more in majority. So we need this group be present in the benzene ring. So we will do what here? We will use nitrating mixture H2SO4. Out of this we will get NO2 group, and this NO2 group will enter in the para position. Now, in our question, the demand of question is that finally we should get benzaldehyde. So this is chromal chloride. Am I right? So in ethyl reaction we have got it. CH3 becomes CHO in presence of CrO2 Cl2. So this is very simple. So we have prepared 1214 page 386 of your text. Benzene, out of benzene, 2 butane 1,3 diol. Mind that whenever your starting material is ethanol, you should think of the chapter aldehyde and ketone. And from aldehyde and ketone, ethanol means there is 2 carbon, and butane 1,3 diol means you are getting what? 4 carbon. So to extend the chain, it is only possible in aldol condensation. Aldol condensation process. What is aldol condensation? Simple sodium chloride in dilute. 2 molecules of the same thing will repeat, will give you the aldol condensation. So condense means 2 ethanol, when it is condensed, 2 carbon is there, we will get 4 carbon. Then we will think of how we will get diol or whatever this. Our leading idea to get 4 carbon out of 2 carbon in aldehyde chapter or ketone chapter, we need aldol condensation sodium hydroxide. So now what is ethanol? CH3 C double bond of H. It is ethanol. Another ethanol is same molecule, it is aldol condensation. The style of writing is CH2 CH2. We can write CH3 CH3 CHO CH3 CHO. Why you have written in this way? It is the technique of writing, because in each and every time it is not possible for us to saw the mechanism, because in the mechanism I have shown you in aldol condensation mechanisms, one nucleophile is get attached. Nucleophilic addition is that nucleophile is there. What is nucleophile? This is alpha. Am I right? This is alpha carbon. Alpha hydrogen is there. The essential criteria of the aldol condensation is that aldehyde should contain alpha hydrogen. So alpha, we will always concentrate upon alpha hydrogen. So alpha hydrogen is there, we have written, that's why you have written alpha hydrogen in this way. CH3 group is, CHO group is there, adjacent to this one is alpha hydrogen, and simple you write in this way, CH3 CH, this is in this way, O, and that hydrogen is here. If you don't know the mechanism I am showing you, and you write. So we have got 1 2 3 4 butane, but we don't know how we will get 1,3 diol, because we have got all NL aldol. Am I right? From all and aldol. So best way to write this is in this way. Am I right? So our technique is, if we want to get two all in two position all, we need reduction of CHO. Am I right? So reduction of CHO, lithium aluminum hydride. So one hydrogen will be attached here and other hydrogen will be attached here. So this is reduction, is means addition of hydrogen. I have shown a lot of times. OH and H, CH2C, OH, one H here, other H here, means CH, H means CH2 OH. Or you can write here. Am I right? You can write here. So you see 1, 2, 3, 4, 1,3 diol, butane 1,3 diol. If you don't know the rule or process, you can't. Up to this much you can very easily do, but often you can't convert this one into alcohol. You know CHO becomes CH2 in other word on reduction. Simply those who don't know the reason H and H, how it adds up, simply write one hydrogen here, one hydrogen here, double bond, you will face one bond, this will be on the otherwise you write CHO becomes CH2 on reduction. Am I right? So this is ethanol to but to in L. Again you see your target is from 2 carbon, you are getting 4 carbon, it is nothing but aldol condensation. In a very speedy way you can write 2 molecule, am I right? There is 2 molecule, CH3 C double bond OH, 2 molecule get attached. So first molecule will be like this, CC. I am writing in a speedy way. O will become H, and that H will come from here, and that hydrogen is of this one, and if one H goes here, this is CH2, CH2, CH2. This is your answer. 1, 2, 3. But to, oh yes, in L, am I right? In L there is double bond, and it is very easily known to you. I have already mentioned you, if this product is there and if you apply heat, what's happen, one hydrogen you write in this way, it is not water elimination. I am telling you the mechanism in other ways. I have shown you first day. These two group will removes out, it is not water, OH and H will go out, and there will be double bond. So you see CH3, this is CH double bond, CH CHO. So 1 2, am I right? But 2 in L, but 2 in L, this is the answer. When aldol condensation answer is there, you just give heat, you will get alkene. These two groups will be removed. I have shown you the mechanism. I am not explaining once again the process. Ethanol to but to enoic acid. Nothing, very simple. Again but ethanol. So blindly you 2 molecule of aldol condensation. Am I right? You write same way I have shown you. Okay. So what's happened? The answer is sodium hydroxide is there, dilute CH3 C OH H CH2 CHO, but here oic means C double OH group is there, so we need to convert this group into oic. You give oxidizing agent on oxidation, that will become CH3 CH OH, or before this it is enoic acid. I am sorry, we need to, when we should get double bond, if we want to get double bond we need heat. So when heat is required we will write in this way. Am I right? So these two group will go away. So CH3 CH double bond CH CHO. Am I right? So now we need to convert this, because the demand of question is oic acid. There is a technique, you can't use any oxidizing agent, because if you use strong oxidizing agent, that double bond will be affected. So we should use such an oxidizing agent which only converts this into COOH, but it doesn't affect this one. So that agent is PCC. And I am telling you for your more knowledge, Mn2 is also another type of oxidizing agent, of weak type of oxidizing agent that doesn't affect double bond and just is convert CHO. These are weak oxidizing agent. So your answer is CH3 CH double bond CH C double bond OH. So be careful about the use of oxidizing agent to get C double OH. When there is another double bonds or another functional groups are there, we should use here PCC. 12.8, question number 12.8 of page number 186 of textbook. Am I right? At the end of this today's class, I will show you cross aldol, which I have not mentioned in the main class, and that was asked in question 2002 to NEET. I will show you the question. So minutely follow what I say and try to practice whatever the way I have shown. Cyclohexane, carbaldehyde. This is again, you open 12.7 of your textbook, question number 12.7 of 386, not 17 of 386. You will get your starting material is this, and from this, these are the questions very often asked in entrance and also competitive exams and all India types of questions and NCERT questions. These questions are being asked. You are asked C6H5 Mg Br and acid hydrolysis. So these things are very important, and I very often tell you, when you write the Grignard reagent, you give this is plus and this is minus. Am I right? When this group oxygen is more electronegative, this bond is, sorry, there is no bond, it is cyclohexane carbaldehyde. So if this bond is withdrawn, this is negative and this part become positive, electron deficient center. Am I right? And that negative one will get attached with this one and positive one will get attached with this one. So what you get here is, answer is very simple, and don't to try to learn by practice. You do with the help of your knowledge. You can. So better you write it this group here. It will be very easy for you to OMG Br. Am I right? OMG Br, and here will be C6H5 and this is H in your question. Am I right? When you hydrolyze it, means OH and H plus. Am I right? Bond breaks in this way. I have shown you many times. So what you get here is, you can write TH or C6H5. Am I right? This is the answer. This is the answer. There should not be any bond. When you use tolerance, what is tolerance? Once again I am showing you SAG NH3 holding to plus and base. So you are asked to make reaction with the same reagent with toluene. Toluene means silver is there, and toluene is a weak oxidizing agent. It reduces this one. So what's happened? If it is a weak oxidizing agent, CHO group will become COOH. This is the main thing. Toluene. This will be oxidized, and here we will get silver mirror ammonia like this, or whatever the byproduct we are not writing. Our main thing is the product. Cyclohexane carboxylate ion. Am I right? Next one is semicarbazide. To make reaction, they have given in this way semicarbazide NH2 NHCOO NH2. This is again very simple reaction. Semicarbazide, very simple reaction. See, I am writing this here. C double bond OH, and that day I told you these are nothing but the ammonia derivative. Am I right? In ammonia, one hydrogen is replaced by any group or atom elements. Am I right? So what's happened? That this NH2 N NHCO NH2, write in this way and just release of water occurs. Am I right? So your answer is CH double bond and triple bond N HCO NH2. Very simple. Carbazide will become semi-carbon cyclo carbaldehyde semi carbazole. Am I right? So what is the next one? Ethanol. Let me write it in proper way. Excess of ethanol. So what's happened here? You write ethanol as, right, C6H of OH. Am I right? Am I right? So what we get? Cyclohexane carbaldehyde diethyl acetal. This is the answer. What is zinc mercury HCl? It is Clemmensen reaction. And in the very first class I told you, Wolff-Kishner reactions and Clemmensen reactions, CO group becomes CH2. So if it is CH2, one H is there, this is methyl cyclohexane. Simple. CH2 becomes, you can write in this way, H remains H and that CH2 become CO become CH2 means CH3. Another type of reaction, KMnNO4. I told you if it is alkyl halide, not 3 degree, 1 degree, 2 degree alkyl halide, that whole part will become carboxylic group. K will come here. Again very simple. COOH. This is phthalic acid and SO, and you are asked to very simple OH. Parallel PHTHO thioloyl chloride. Next one is C6H5 means benzaldehyde is NH2 NHCO NH2. Again this is very simple, C6H5, and you write the H as like this, make it water? The answer is C6H5 CH double bond N CONH NH2. Next one is CHO. You are asked to react with Tollens reagent. So one of the very important thing is here that Tollens reagent reduce CHO and it is a weak oxidizing agent. CHO will go back to COOH. It will never act on ketone. Ketone compound does not take. Carbonyl compound does not make reaction with Tollens or Phelix. Next one is C double O H is made to react with NaCnHCl. NaCl HCN. NaCl HCl. Sodium HCl. That becomes what? These two combines and these two combines. You will get HCN. Simple. In carboxylic group, in aldehyde part, we showed you it is a nucleophilic reaction. Am I right? So here in final mixture we get HCN. From this we will get CN as a nucleophile, and that CN will attack in this group as like this. See here H, here CN, or here H OH and H. Am I right? This is the answer. Very simple. Next one is again very simple, but a bit this is oxidizing. Very often you may not answer this one. It looks very simple thing, but you can't. If it is oxidizing, so what is oxidation? Loss of hydrogen. Am I right? So where from this hydrogen will be lost? The hydrogen will be lost like this. I am showing you, and be care about writing the answer. One hydrogen, there is hydrogen. Am I right? And other has hydrogen there. Just we lost hydrogen from these two. We are losing these two hydrogen. So this bond will be inclined in this way. So be care about writing the answer. Oxidation means loss of hydrogen. We will lose the hydrogen like this. So next one, it is again from first year. Hydroboration reaction. I don't know have you done it or not. B2H diborane, hydrogen peroxide in alkaline medium. The diborane actually borane is BH3 is dimolecular. BH3 double of this B2H6. So what's happened here? Actually a short technique or mechanism, you may say, CH through 3 times occurs. Then when you give peroxide in presence of this is anti-Markovnikov of addition. When peroxide is there, OH group will attach with the carbon having more number of hydrogen. This is carbon, more number of hydrogen. So in that part, if you do not know the rule, you can't. That part, there is carbon and there is carbon. More carbon is here. It is anti-Markovnikov rule. It is just like the product is peroxide effect or crash effect. Am I right? So diborane, wherever there is a question of diborane, it will be alcohol, and alcohol will be at simply, if you can't understand anything, use bond and OH, you add up OH here. This will be your answer. Carbon and carbon, more number of hydrogen, OH will be attached, not less number of hydrogen. This is anti-Markovnikov rule. I have done 40% of the solution. Hope in solution number 2 I will complete with cross-aldol the question which has asked in the last year. Thank you a lot for watching the class. If you find the class interesting, please don't forget to smash like and subscribing button